Hi, welcome to my video, the system of linear equations in two variables. We're going to solve by graphing part 1. We're going to solve by graphing part 1. Solve by graphing. Let's do some examples. We have an equation y equals a half x plus 1 and y equals negative x plus 4. So we're going to graph the two of these equations and see what happens. The first equation has a slope. If we look at the first equation, equation 1, we have a slope of a half, that's the m, and we have the slopes are in relation to the two. Slope of the second one is negative 1. So the two slopes, you notice, are different. And let's look at the y-intercepts. The y-intercept of the equation 1 is 1. The y-intercept of so if we mark this equation 1 and mark that equation 2 when we start, then you'll know what I thought about equation 1 and 2. So equation 2 has a y-intercept of 4, and again the y-intercepts are different. So now let's graph them. Let's graph the first equation, which has a y-intercept of 1. So we graph the y-intercept and then we plot the slope. The y-intercept is 1, so here's the y-axis. The y-intercept is 1 right there, and the slope is 1/2, so up 1, right 2. From this point, from the y-intercept, up 1, right 2. Up 1, right 2. And we draw a line through those 3 points. And here we go. And make sure the more points we have, the better. There it is. And the second line, we have a y-intercept of 4 with a slope of negative 1. That negative 1 slope is negative 1 over 1. So we plot the y-intercept of 4 first. 0, 1, 2, 3, 4. Y-intercept of 4. And the slope is negative 1 over 1. That's down 1, right 1. Down 1, right 1, down 1, right 1. So we have down 1, right 1, down 1, right 1, down 1, right 1. So we draw the line passing through those points. And notice that the point, draw arrowheads on the end of that line because it keeps on going if you wish. And so the point, it says the point, notice, intersects right here. So that's the point. X is 2 and y is 2. So if you go down here, you get x is 2. If you go across here, you get y is 2. So the solution is 2, 2. So we're solving by graphing. And now, the number of solutions that's in this system is 1. And because it's a point, there's only one point, the two lines are intersecting. Notice the two slopes are different. When you have two lines intersecting, because the slopes are different, you'll have one point of intersection, and the point is 2, 2. And the name of this system is consistent independent. Just reviewing what we've learned so far. So that's the name. Now let's do the second one to see what happens. And in the second one, we have, we're solving y equals negative half x plus 3. Y equals negative half x minus 2. So the slope of the first equation is a negative half. The slope of the second equation is negative half. And they're the same. In the y-intercept of the first, remember, okay, that's the first one. So when we're solving systems, we should number the equations. Or at least I should number them to let you know what we're talking about. Sometimes when you're solving, you let the teacher know what you're talking about. So number your equations. So the first equation got a y-intercept of 3. And the second equation got a y-intercept of negative 1. So notice numbering equations, it becomes plainer. And the y-intercepts are different. They're not the same. And let's plot those two equations to see what happens. The y-intercept is 3. So there's 0, 1, 2, 3 right there. That's the y-intercept of 3. and you go down 1, right 2, down 1, right 2, down 1, right 2. And if we plot that line going through those 3 points, let's see what we have here. Here we go. And you put an arrowhead on because the points go on and on and on forever. And the next one, we have a y-intercept number 2. So that's number 1. Number 2, the y-intercept is -1, which is right there. There's 0, -1 on the y. And we go down 1, right 3. Down 1, right, oh sorry. Down 1, right 2. Down 1, right 2. Down 1, right 2. And we draw the line through those 3 points. And if you notice, it looks like the 2 lines are parallel to each other. Notice you have what? The same slopes. If 2 lines have the same slopes, then and notice they got the same slopes and different y-intercepts, so they're going to be parallel to each other. So the solution to this equation, there's no solution. What we call the empty set, 0 with a stroke through it, is the empty set. There's no solution. There's no points. All the points on this line, there's none of them on this line. The number of solutions to this system is none. There's none. And the name of this system is inconsistent. Inconsistent system is parallel lines, no solution. They do not intersect. Okay, let's continue. Solve by graphing, practice. And a practice means you work these out. Pause your video and work these out. And when you're doing these, if you're doing graphing, then you pause your video and go and get some graph paper and plot these lines. Here I go. I'm going to take the first line, and that's the second line. So the first equation has a slope of 1. And the second equation got a slope of -3/2. Remember, y equals mx plus b. And the m is the slope, which is 1, and -3/2 the y-intercept. And let's pick up the y-intercept. First one is -6, and then the second one is -1. And the slopes are different, and the y-intercepts are different. Slopes are different, y-intercept is different. And so let's plot these two. We got a y-intercept of -6. That's right down there. There's 0, -1, -2, 3, 4, -5, right there. And we will go, slope is 1, so it's 1/1. So that means I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. So I'm going to draw the line going through those points. And there it should be, right here. And the line goes on and on. Put arrowheads on the end. Let's plot the next line. The y-intercept is -1. So the y-axis, y-intercept is -1 right there. And we go down 3, right 2. Down 1, 2, 3, right 2. And down 3, right 2. Well, it's about here, I'm off a bit, but you can see I got to draw it down 1, 2, 3, right 2. So I got these 2 points here, and the one I partially plotted there. These two will do it. And notice the 2 lines intersect here. Notice the slopes are different. If you have 2 lines and you're looking at their slopes, if they have different slopes, the line will intersect at one point. So the solution here, if you go up here, x is 2, and you go across here, y is -4. So the solution is x is 2, y is -4. The number of solutions is 1, is a point, and the name of the system is consistent, independent. Remember, learn this, memorize it in case, or ask your teacher if you got to know it, and if you stressed it. Number 2, we have these two equations, and we got y equals 2x plus 1, y equals 2x minus 3. This is equation 1. This is equation 2. And equation 1, which is this one, the slope is 2. In equation 2, which is this one, the slope is 2. Remember, y equals mx plus b. M is your slope. And the slopes are the same. And let's look at the y-intercepts in equation 1. Y-intercept in equation 1 is 1. The y-intercept in equation 2 is negative 3. And the y-intercepts are different. And what do you predict? Well, if you've got the same slopes, different y-intercepts, then the lines are not going to intersect. So here we go. Take the first equation. Y-intercept is 1, which is right there. Remember, that's a 0. Y is 1 right there. And 2 is 2 over 1. Understood to be 2 over 1. So from this y-intercept, 2 over 1, you rise 2 and go right 1. Rise 2, go right 1. So let's draw a line to the 3 of those points. Again, 2 points will do it, but I always like to draw a third one and line it up. And to draw the second one, I have a y-intercept of negative 3, negative 1, negative 2, negative 3. The y-intercept is negative 3 on the y-axis right there. And the slope is 2, or 2 over 1. So you rise 2, run 1, rise 2, and go to the right 1, rise 2, and go to the right 1. And I draw a line to those points. And there it is. And it looks like the two lines are parallel to each other. Yes, and we can see because they got the same slopes. So the solution is what they call the empty set, or there's no solution. It's spell solution. I can't. No solution, or what we call the empty set, a circle with a stroke to it. No empty set. Number of solutions is none, and it's a I almost made a mistake then. Inconsistent. An inconsistent system is a pair of parallel lines. And let's continue. So you're plotting the two lines, finding the point of intersection if there's any. And if there's none, then you've got parallel lines and you've got no solution. Solve by graphing. We have these two equations. So this is equation 1. This is equation 2. Equation 1, the slope is a half. The y-intercept is negative 4. Oh, I better put the y-intercept down here. Equation 2, the slope is negative 2. And the y-intercept is 2. So I could do the two slopes first, which is a half and negative 2. And then I could do the two y-intercepts, because the way I have it organized. And notice the y-intercepts are different. Oops. Slopes are different, and the y-intercepts are different. Right, I get ahead of myself. So the slopes are different. That means if you've got different slopes, the two lines are going to intersect in a point. Let's see what that point is going to be. And we have a y-intercept of negative 4. 1, 2, 3, negative 4 is down there. And we rise, we go up 1, right 2. Up 1, right 2. Up 1, right 2. So I draw a line going through those 3 points. And there it is there. And now we have to graph the second one. X is negative 2 on the y-intercept. Right there. X is 0 there. 1, 2. X is negative 2. Sorry, X is positive 2. Better be careful. And the slope is negative 2 over 1. So from here, which is my y-intercept 2, I will go down 2, right 1. Down 2, right 1. Down 2, right 1. So I'll draw a line So those points, here we go. And you notice the point is right here. There's two different slopes of a half and -2, and the points, the lines intersect. But solving this, now we have to estimate these two. So we're really doing an estimation on this. And when we solve by graphing, normally, most times when you're solving by graphing, if you intersect at a point, it will intersect right on, like a corner. It will intersect here, let's say to be 3, 1, or it'll intersect here, which is -1, -1. So to get this question and solve by graphing, normally you wouldn't get it because you got to estimate the answers, and the answers are not going to be true because you don't know what fraction is. So this is like x is 1, 2, x is 2, and what? Is it a quarter? Is it a third? Is it 2/5? And the y is 1, 2. So y is going to be negative, whatever. Negative is down further, so it could be 3/4. It could be -2 3/4. So I can take a guess. I know I got one solution. I know the system is consistent, independent. But normally I did this on purpose because you would not be asked to solve this by graphing. You would be asked to solve this by one of the other methods, which is one called elimination or substitution. So I can feel approximation, but it won't be true, because when I put these, whatever I'm going to put in this, whatever I put in here, and I put back in the equation, it won't make the equation true because I'm estimating. The next video will have the third system of equations. So also notice that you don't have the system of consistent dependent, because consistent dependent is the same line, and I couldn't do that in graphing, but I will have it in my next video. So solve by graphing is one way. We have two more methods to learn also. If you like my video, click the like button, click the subscribe button, and the notification bell. More videos are coming your way. Visit my website at www.mathfullyexplained.com to find out more information on me, my videos, and the content on the YouTube channel. Thank you for viewing my video. Bye-bye.